click a link in an email and your bank sends $1,000 to a stranger. You didn't type your password, you didn't confirm anything, you just visited a page. This is called Cross-Site Request Forgery, and I'm going to show you exactly how it works. Forgery means to produce a fraudulent copy or imitation. Request refers to HTTP requests, those messages sent between your browser and a web server. And cross-site just means another website. Put it all together, CSRF is when a malicious website forges a request from your browser to another website that appears to come from you. Wait, that sounds impossible, right? Banks have security. You need to be logged in. You need two-factor authentication. So how does this work? The answer comes down to one word, and once you understand it, CSRF will suddenly make perfect sense. It all has to do with how websites identify users. When you log into a website, the server needs a way to remember that you're logged in. Otherwise, you'd have to log in again every time you click a link or load a new page. The solution? Cookies. When you log in, the server sends your browser a cookie, a small piece of data that says this is Daniel and he's authenticated. And from now on, every time you make a request to that website, your browser automatically attaches that cookie. And that word, automatically, is the entire reason CSRF works. Let's say that you're logged into your bank. Now you open a new tab. Maybe you clicked a link in an email. Maybe you're just browsing. You land on a malicious website. That website has a hidden form on the page. You can't see it, but the moment the page loads, it submits a request to your bank. Something like transfer $500 to this account. And here's the problem. That request is going to your bank, and your browser still has that cookie, so it automatically attaches it. The bank receives the request, checks the cookie, checks that the session is valid, and approves the transaction. As far as the bank can tell, you made that request. That $1,000 transfer from the start, that's exactly how it happened. You didn't click anything, you didn't confirm anything, you just visited a page. Your bank was just the example. Think about how many sites you're logged into right now. Gmail, Instagram, Facebook, your work apps. Every single one of those has a session cookie sitting in your browser, ready to be automatically attached to any request. CSRF doesn't care what the site is. If you're logged in and there's no protection in place, it's vulnerable. And this isn't hypothetical. This has happened to sites that you've definitely used. In 2008, if you visited one wrong page while logged into YouTube, it would automatically subscribe your account to channels, add videos to your favorites, and send messages from your account without you clicking anything. And in 2020, a TikTok CSRF bug meant someone could delete your videos, expose your private content, and access your account data just by getting you to visit one page. So how do we stop this? Well, the problem is clear. Your bank can't tell the difference between a request you made and one that was forged on your behalf. The cookies look the same either way. So we need something extra, something that isn't sent automatically, something that could only have come from the legitimate website. That's exactly what a CSRF token is. When the server sends you the transfer form, it embeds a randomly generated secret value as a hidden field, unique to your session. When you submit the form, that token gets sent along with your request. Your bank checks for it. If it's missing or wrong, the request is rejected. The malicious site can try forge the form, but it can't include the right token because it doesn't have it. Another layer of security is the same site cookie attribute. This tells your browser not to attach your cookie on cross-site requests at all. Chrome even started defaulting to this behavior in 2020, but CSRF tokens remain the primary defense you implement as a developer. And that's cross-site request forgery. One word, automatically, is the entire reason it works. And two things stop it: a token that only the real site could have sent, and a cookie that won't attach to requests from anywhere else. If you're a developer, check your framework. Most modern ones handle CSRF for you. Make sure it's enabled. If you're just trying to understand how the web works, now you do. At least one more piece of it. If this was useful, subscribe. I cover web security in plain English, one vulnerability at a time. See you in the next one.